is AP Physics B, section 1.6. We're going to look at vector addition and subtraction. We're going to look at how to add vectors. We're going to look at how to add vectors linearly, or how to add linear vectors, how to use the parallelogram method, and how to use the head-to-tail method to add vectors. We're also going to look at how to subtract vectors. We're going to look at the collinear example first. If we have, for example, a vector that is that we walk 6 meters east, and then we walk another 5 meters east, the resultant vector is 11 meters east. And you might have, you walk 6 meters, you might have 6 meters east, and you might have 5 meters west. That resultant vector is 1 meter to the east. Now we're going to look at the parallelogram method for adding vectors. We'll have a vector, for example, you might have one vector going off to the east, and you might have another vector coming up this way, and you might be pulling on a car or something like that. Now we want to find out what the resultant vector is. So you draw a parallelogram here, and your resultant vector is from the corner where the object is, to the far corner. So resultant vector is right here. And you just draw a parallelogram and find that vector. And if you know the size and angles and so on, you could find out what that resultant vector is. You'd either have to use law of cosines or Pythagorean theorem, things like that. In this case, you couldn't use the Pythagorean theorem because for an angle. So I'm going to draw 2 more vectors. I'm going to have you try it yourself. We'll be pulling on this object here. We'll have one vector off in this direction, another vector off in this direction, and what I would like you to do is to pause the video and find out what the resultant is using the parallelogram method. If you use the parallelogram method correctly, you would draw this parallelogram like this, and the resultant vector is from where the object is up to the far corner. So that would have been the resultant vector there. Now we're going to look at the head-to-tail method example. And the typical example of that would be a vector like this, and then another vector coming up like that. And the resultant vector is from where you started to where you ended. So from where I start to where I end would be my resultant vector. And you may have vectors. This may be a path that you're walking. You may be walking all sorts of different directions. And the vector, your resultant vector, is from where you started down to where you ended. So that's your resultant vector. And I'm going to give one more example, and I'd like you to try that. Just pause the video and try this problem here. Where we have the head-to-tail method, and I'd like you to draw the resultant. And the result would be from where you start to where you end. So that would be the resultant vector there. Okay, here is an example, an animation of adding vectors, and we have these 2 vectors here. Again, pause the video. You can add the vectors up, and they're going to show you how to add these head to tail. So what they did was they moved that one vector, the tail of one vector, the head of the other vector, and drew that result. What I want you to do is we're going to try 3 now. See if you can add these 3 vectors, head to tail. Pause the video. Try it out yourself again. This is what it looks like. Vectors up head to tail, and there's your resultant vector there. Okay, we'll try one more. We'll try 4 vectors here. Pause the video, try this yourself, see if you can add them head to tail, see if you come up with the same result they do. And they've been adding these vectors head to tail, and you see the result there. Now we're going to look at vector subtraction. And vector subtraction is the same as vector addition, except that one vector being subtracted is in the opposite direction. In practice, vector subtraction is carried out exactly like vector addition, except that one of the vectors added is multiplied by a factor of -1. So what does that mean? That means we can calculate vector A as, for example, A equals C minus B, which is an example of vector subtraction. How do we handle that situation? Well, what we do is we change it over. We rewrite it as an addition. You can always write subtraction as addition. So you take B and make it negative, and then you can have vector A equals C plus a negative B. That negative B, all that means is the direction is in the opposite direction. The magnitude of B is exactly the same, but now you just reverse the direction of vector B. So let's take a look at what that means exactly. We'll do an example of that right now. So for example, we might want to add two vectors here. We have vector A, looking like this. So let's say we have vector B here. And we know that if we were just to do A plus B, our resultant would be from where I started to where I ended, right there. That would be our resultant vector if we want to do A plus B. Well, let's say we want to do A minus B. Well, if I want to do A minus B, well, I draw vector A. Just rewrite this here, A minus B. I have to realize I want to think of it as being A plus negative B. So I'm going to go ahead and write out my vector A here. And negative B is exactly the same as B, except now it's in the opposite direction. That is negative B right there. And so this is my resultant vector. That is the resultant, which is equal to A minus B. All right, well, let's look at another example here, and let's go ahead and see if we can calculate what A minus B would look like in this case. Well, here we have vectors A and B. So the first thing, again, we have to do is convert that to be A plus a negative B. So we have to decide what direction negative B is in. And so can you go ahead and pause the video and draw your negative B? Okay, so your negative B should look like that. It's the exact same magnitude, but in the opposite direction. So what we want to do is we want to have our A plus negative B. So we're going to take our A vector, and we want that to be our first vector. That'll be our A vector. And let's add this head to tail. A plus a negative B. So we take our negative B vector, and then we move that here. So there's our A plus a negative B. So our resultant vector should be from where I started to where I ended. And if you draw out that vector from where you start to where you end up with this vector here, which is A minus B. In other words, it's A plus the negative B. Okay, now we're going to wrap up this section here. What we've seen is how to add and subtract vectors, the different methods and so on, the different methods for adding vectors, and we've finished off by subtracting vectors, showing that subtracting vectors is similar to adding vectors.